Well, good evening and welcome back for the notes for section 11.5, which is called Angle Relationships in Circles. We will be looking at how some different angles are set up, whether the vertices of those angles are actually on the circle or outside the circle maybe, or even somewhere inside of the circle, maybe not as specifically as what we've talked about before. The first that we're going to talk about is a tangent chord angle, which is actually, as the name suggests, is an angle that is formed by a tangent as well as a chord. And notice that the vertex here is actually on that circle. And if you know the measure of this intercepted arc, which in this specific case is 120 degrees, what we know about a tangent chord angle is that the measure of that angle is half of this intercepted arc. Alright, and that's what all of this is saying right here. So the tangent chord angle, this specific situation here, is equal to half of the intercepted arc. So in this particular case, angle X would be equal to 60 degrees. So an angle formed inside of a circle by two intersecting chords. Alright, now this was, let me go back. This was the first situation, was the tangent chord angle where the vertex is actually on the circle, and this was formed by a tangent and a chord. That was actually the measure of half of its intercepted arc. Well, now we're going to move on to where we actually have two chords here. CD is a chord and AB is a chord. And this angle X right here is going to be found by finding the sum of the two intercepted arcs. Now it's not just equal to the sum of the intercepted arcs, it is actually equal to half of the sum of the intercepted arcs. So if we wanted to find X, we know that these intercepted arcs, BD is one of the intercepted arcs, AC is the other. And when I'm saying the intercepted arcs, I'm talking about the intercepted arcs formed by these vertical angles. So what we can do is we can add the 70 to the 170, and that will give us 240. The measure of angle X there, or what we would call BED, but where this X is, that is actually equal to half of that angle. So the measure of that angle in this particular case would be 120 degrees. An angle that's formed outside of the circle. I told you we were going to go through several situations. There are different situations where this could happen. For example, if there are two tangents, notice here, AB is a tangent line, BC is also a tangent line. Alright, that's one situation where we could actually have an angle that's in the exterior or outside of the circle, in this case formed by two tangents. If you have two secants, remember the difference between the secants and the tangents. If you have two secants, this is another situation where the angle could be outside of the circle. If you have a tangent and a secant, again, you have an angle which is formed on the outside of the circle. The vertex is in the outside of the circle. What you'll notice here is that in every single situation, the measure of that angle is equal to, you might want to write this down, is equal to half the difference of the intercepted arcs. Now notice that says half the difference of the intercepted arcs. If you look at the slide before this, this was equal to the half of the sum of the intercepted arcs. So when the angles are inside, then you're adding these two arcs and taking half of that sum. When the angle is on the outside, you're actually subtracting these two arcs. So this is actually all written out for you right here. If I'm going too fast, you may want to just pause this. But to find the measure of angle X, then you would take 260 minus 100, which is right here, and then take half of that sum. So 260 minus 100 is 160 degrees. Take half of that, and that would equal 80 degrees. Likewise, here, if you have to find the measure of this angle where X is, angle C, then you would take 80 minus 20, which is 60. Okay, this actually was not take that. You would take 80 minus 20, and then once you find that difference, you're going to take half of that difference. Okay, so 80 minus 20 is 60. take half of that, that would be 30 degrees. Alright, likewise here, when you have a tangent and a secant, to find the measure of this angle, you're going to take 100 minus 30, which I think we can just go ahead and do this, which will be 70. We're going to find half of that, which would be 35 degrees. Alright, so again, inside, if the angle is inside, you're going to add these two arcs and take half of that half of that sum. If the angle is on the outside, then you take the difference between those two. We're subtracting that. So let's apply those. If we want to find the measure of EFH, angle EFH, well, notice this is actually set up pretty nicely. Angle EFH is right there. The measure of its intercepted arc is 130 degrees. So to find the measure of this angle, angle EFH, whoa, I don't know what I just did there. Let's just erase that. I could actually edit this, but that would be way too easy. So I'm just going to go back and let you watch my mistake here. I would take half of that 130 degrees, which is 65 degrees. Alright. If I were to find the measure of arc GH, now remember, the measure of the arc is actually equal to, the arc itself will be twice the measure of the angle that is intercepting that arc. Well, the thing is, we're not given that. But if we knew what the measure of that was, well, that would be helpful. This angle right here, which is its supplement, is 122 degrees. What that would mean is that this angle, angle FG, make up your own letter here, would have to be 58 degrees. So to find the measure of arc FG, since the measure of this angle is half of the intercepted arc, 58 is half of 116 degrees. So the measure of arc GH will be 116 degrees.